What if humanity made the ultimate leap? What if we broke the universe's greatest law and learned to travel faster than light? This isn't just a dream. It's a fundamental prohibition. The speed of light, 299,792,458 meters per second, in a vacuum. And it's not just a ceiling, it's a wall baked into the very fabric of reality by Albert Einstein's theory of relativity. You see, it's all about mass. Any object that has it cannot reach that speed, because as it accelerates, its mass increases. This requires more and more energy. And right at the threshold of light speed, that energy requirement approaches infinity. Simply put, to accelerate even a small starship to light speed would require more energy than exists in the entire observable universe. But let's imagine we tried. What would happen to the ship and its crew? The consequences would be fantastic and terrifying. First, collisions. At such velocities, even a microscopic dust grain, a hydrogen atom, would carry the energy of a powerful atomic bomb. Shielding against that is an almost impossible task. Second time, according to relativity, time for the moving object slows down. For a crew traveling at, say, 99.99% of light speed, only a few years might pass. But back on Earth, 1,000 years would have gone by. They would fly into the future. Returning to their own era would be impossible. Third, the view. Due to the Doppler effect, the light ahead would blue shift into an invisible, blinding ultraviolet point. And behind, it would redshift into utter darkness. You would be flying through a tunnel of distorted, insane light. So, it's clear a direct assault on this law is doomed. We cannot accelerate a ship to that speed. But what if we don't move the ship? What if instead we move the space-time around it? This is where we move from science fiction to theoretical physics. In 1994, Mexican physicist Miguel Alcubierre proposed a clever solution, now known as the Alcubierre drive or warp drive. Imagine a spaceship inside a bubble, a warp bubble. The idea is this: space-time ahead of the ship is artificially compressed, and the space-time behind the ship is stretched, expanded. The ship itself inside the bubble remains stationary. It does not accelerate in the classical sense. It is the space around it that moves like a wave, carrying the ship at superluminal speed. It's like standing on a surfboard on the crest of a wave. The water moves, but you stay in place. But to create such a wave of space-time, you need exotic matter with negative energy or negative mass. For now, we only theorize that such matter could exist. It is the key. If we ever find it or learn to create it, the game changes forever. So let's say we did it. We have a warp drive. What next? How would humanity use this power? First, and most obvious, is the golden age of galactic exploration. Distances collapse. Proxima Centauri, the nearest star, not a 4+ light-year journey, but perhaps a matter of weeks or days. We would no longer send lonely probes that take decades to reach a single target. We would send fleets. We would build colonies around Tau Ceti, Epsilon Eridani. We would swim in the oceans of Europa and watch a triple sunset in the Alpha Centauri system. The galaxy would transform from a picture in a book into our backyard. Second, communication and unity. The biggest obstacle to an interstellar civilization is the silence. A simple question to a colony 10 light years away takes 20 years to get a reply. But with ships that can outrun light, we could establish a real-time or near real-time communication network. Courier ships carrying data crystals could link worlds. A unified human culture spanning stars becomes possible. The internet becomes the galaxy net. Third, resource revolution and new conflicts. An asteroid made of solid platinum in a system 20 light years away? Now it's a mining prospect. A planet with unique biological compounds? A pharmaceutical gold mine. The economy would explode in scale. But with new frontiers come new tensions. Who controls the warp lanes? Is a warp-capable ship the ultimate humanitarian vessel, delivering aid anywhere in an instant? Or is it the ultimate weapon, capable of appearing above a planet without warning? The very concept of defense would be rewritten overnight. But every great leap casts a long shadow. And breaking the light barrier wouldn't just change where we go, it would change what we are. It would force answers to questions we've only dared to whisper. For instance, the Fermi paradox. Where is everybody? If faster-than-light travel is possible, and we just achieved it, are we the first? Or is our sudden, noisy emergence onto the galactic stage like slamming a door in a quiet, dark room? We might solve the greatest cosmic mystery in an instant. The answer might be wonderful, or it might be a final warning. Then there's the concept of home. When you could be anywhere in the galaxy by next Tuesday, what does Earth become? Is it still the cradle of humanity? Or does it become a historical park, a museum world? Our identity, tied to a single pale blue dot, would fundamentally change. We would become a truly interstellar species, and that carries a profound psychological weight. And the most mind-bending consequence of all, time travel. Some physicists have shown that the mathematics of a working warp drive are eerily similar to the mathematics of a closed time-like curve, a fancy term for a time machine. By creating a warp bubble and moving along specific paths, you might not just travel through space, but through time. Arrive at your destination before you left. This isn't just speculation. It's a serious implication of the equations. We would have to grapple with paradoxes we thought were confined to fiction. The responsibility would be staggering. So, what if we broke the light barrier? It would be our species' final graduation. A step from the flat Earth to the round one, from the ocean shore to the new world, but on a cosmic scale. It promises an end to loneliness, offering a universe of infinite wonders, new homes, and knowledge beyond our wildest dreams. But it demands a price. Our safety, our certainty, our simple understanding of cause and effect. We would trade the quiet comfort of our cosmic island for the terrifying and magnificent currents of the galactic ocean. The question, then, is not just could we. The question is, when we finally look into that warp tunnel, stretching towards infinity, yes.